Welcome, everybody, to the public defense of my PhD dissertation, a design science research knowledge base for intelligence amplification. Before we get started, I would like to introduce both my paronyms to you, Elisa Osted and Bernard Diphoorn, who are both very close to me throughout the whole process. Please be seated. Let me take you on a short journey in my PhD research and introduce this concept of intelligence amplification. Here you see a nice cartoon which is made by UT cartoonist Louvain to get you into the thinking mode about this intelligence amplification. Human intelligence and artificial intelligence, which is in computers, are quite different from each other. And when we look to intelligence amplification, as depicted here, we try to teach computers how the human brain works, so we can extend our brain with artificial intelligence. In the 50s, the famous neuroscientist Ashby was the first to coin the term intelligence amplification, and he described intelligence amplification using this quote: "So if we want to develop intelligence, then we somehow must construct amplifiers for our brain, small devices, that when we put a little intelligence in it, it will emit a lot." This is quite abstract, but it was inspired by the amplification of sound. I think everybody here in the room has some kind of a sound device at home, and when you put music in, you can switch it to louder or softer. And Ashby basically tried to do the same with intelligence. So here we see the normal distribution of intelligence, and he thought, well, can we use some AI to make us smarter somehow? So it's not possible to go into AI development and try to make 110, 112. But in his opinion, it is possible to amplify parts of the brain. Let me give you an example for you to illustrate this. Here you see a person from Eindhoven, the Netherlands, who has multiple world records in mental arithmetic. He's very good and skilled in doing calculations. He spent his whole life working as a tire salesman, and throughout his career he managed to do very fast and accurate calculations, as depicted here, so very complex things. Of course, there are lots of different aids that you can use, such as a calculator. And throughout the years, throughout the decades, throughout centuries, people have been working on tools that let us calculate faster and more accurate. So here you see a historical view of the abacus, some mechanical devices, electronic devices, and nowadays we have a smartwatch on our wrist where we even can talk to conduct calculations. And these devices have proven reliable and help us calculate faster and with less error. If we want to measure intelligence amplification, in literature there is an equation that we can use to measure the impact of these tools. I will explain it to you with the examples. So here again we see the world record holder, who is a human conducting a specific task, doing calculations, resulting into a performance. So having accurate answers to the equations and doing it in time, etc. And here we can calculate again. This is a person from Asia's Got Talent. He's called the human calculator, also a very gifted person. So we can compare both humans together to see if they can achieve the same performance. But as you can see here, also the person holds a calculator. So different artifacts, as we saw in the previous slide, we can test in different settings to see which one has actually an amplification effect. So this is a way how we can actually measure intelligence amplification. But this, of course, happens in a specific context. We can do this at home when we're relaxed. We can do it in the supermarket when we want to check if the price is okay. We can do it here. We can be a little bit more stressed when doing that. So context matters a lot. And this is actually what brings me to the part of my research. Please come in, have a seat. About the disciplinary perspective. So my research is part of the information systems research discipline, which in short is studying the use of computers in organizations. More abstractly, we study how information technology artifacts, such as the calculators, such as the smartwatch, work within so-called human-machine systems. So it's the interaction between humans and technology that we study. Within this discipline, design science research is a very well-established research paradigm. And we use design science research to design and to investigate artifacts in context. For example, within an organizational context. And more abstract, next to artifacts, we also try to develop new design knowledge and also design theory. So here the design science comes in. Having explained this intelligence amplification and the information systems perspective, I would like to highlight the main contributions of my work by summing up the problems that are in my dissertation and the contributions. So at first, we see that there is a lot of design knowledge out there. So it's not a new phenomenon, and there's a lot being written about this. However, all this design knowledge lies scattered over different disciplines, different fields, and different articles, books. And what I did in my research is to conduct a systematic literature review where I harmonized knowledge from 176 studies to extract the right design knowledge. So this can be quite effective, but it's very inefficient. So it took me a few months to do this, and that brings me to the second problem. The search for this design knowledge is very inefficient at current. And in order to improve this, I developed a design science research knowledge base as a system where we can have all this design knowledge from this 176 studies available at the fingertips. So we can actually go in, we can look for design theories, we can look for methods, and we can see what's out there. Third, when we look to actual design of intelligence amplification, so if you want to build an amplifier, this is a very complex task. And here there are existing design theories that can guide us. And in my research, I improved 2 of these design theories, and I developed a new theory, because the other 2 were from the 1950s, so it was good to have a theory that uses today's technology. Fourth, when we started talking to people from practice, we experienced that they experienced a lack of comprehensive tools. So it's very difficult to get started into designing and developing these intelligence amplifiers. And in order to treat this, we developed a design canvas, a design method, and a toolbox where everybody can get started with this design process. To conclude, I will highlight a few of these contributions in a little bit more detail. So at first we need a knowledge base. So we have a platform that we want to build, a platform of knowledge, and we're going to collect all what's out there in literature. On the right-hand side, you see a keyword analysis that I did based on 3,000 papers. So 11,000 keywords are within this data set, and we try to filter out what are the key concepts, the keywords that we should be looking at. And here we can see that next to intelligence amplification, there are quite a lot of synonyms that we also have to study. And on the right-hand side, you see a table representing all the design knowledge that I identified and also categorized. So descriptive knowledge, prescriptive knowledge, all kinds of knowledge that's out there. It's in the thesis, but just to highlight one, I want to give you my definition for intelligence amplification. So within the different studies, I analyzed 20 definitions of intelligence amplification, also common synonyms. So here you see intelligence amplification, but also intelligence augmentation, and you see also at the bottom cognition. So cognition and intelligence are quite related to each other. So we need cognition to build intelligence, but intelligence is not just good cognition. It's ability to adapt it and to use it in different contexts. So that's why I propose a new definition for intelligence amplification by defining it as the effective use of IT to augment human intelligence in a given context. So now we have all this design knowledge in, we can build our system. So to basically to connect this library and to make it of use of people. And therefore we have to answer this question, how are we going to represent all this knowledge in a system? So as you can see here, design theories are often described in text. You have different models, methods, and how can we put this in a system? Therefore we use what we call ontology, which is basically a blueprint where we systematically organize different types of knowledge, for example, conceptual knowledge, prescriptive knowledge, descriptive knowledge. And this is the basis to build actually this interactive knowledge-based system, which we actually did in the research. So here you see a screenshot of the interactive tool that we developed. And we used this design knowledge from 176 papers to populate the system so that you can actually query it and look for existing design theories, design methods, as seen here. And in my research, I used this tool to improve existing theories and also come up with a new theory. More practically speaking, we want to build something like a launchpad so that we can easily get into this platform and start developing these applications. And therefore, I developed a design canvas. It looks like the business model design canvas, and it helps to basically define the key building blocks of an intelligence amplification application. Next to that, we extended this into a design method, also with help of our illustrator, to make it very nice also for people from industry to get engaged, to connect to experts who are knowledgeable about AI or IT, and to actually start designing a prototype that we can verify. And later on, if it's feasible, we try to implement this and evaluate it within an organizational context. And these tools we evaluated in our own design lab here at the University of Twente with 27 different organizations. And we also took it to Japan to see if it works in a totally different cultural setting. And there we conducted the same experiments at the global IT company and at the Japanese government. So this taken together was consolidated in a toolbox and also a learning environment. And if you have the book, you also find a voucher to join one of our workshops. But now I need to conclude due to time. And here we have a nice platform, the result of 2 years of hard work. But as you can see, there's also a platform ahead. So it doesn't stop here. And that's what we call cumulative knowledge development. I will stop my presentation by introducing the graduation committee, consisting of Maria Iacob, who could not be here today, unfortunately, Martin van Sinderen, Yoshimasa Masuda, Karaca, then we have Jos van Hilgersberg, Maya de Neva, we have Dimka Kalastoyanova, and Saida Sar. And with this, I conclude and look forward to questions. Thank you.
This is the thing.
Please be seated. I hereby open this public meeting of the Doctorate Board of the University of Twente. very warm welcome to all of you here in the audience, the near family, friends, colleagues of the candidate. Also a special welcome to the Defense Committee present here today, and let me introduce them to you. We have Professor Assar from Institut Mines Telecom Business School, a specialist in information systems design and analysis. We have Professor Kara Stoyanova from University of Groningen, a professor in information systems. We have Dr. Daneva from University of Twente, specialized in cybersecurity and semantics. We have Professor Van Hilligersberg of University of Twente, specialist in design and implementation of information systems. We have Dr. Karaca of University of Twente, expert in philosophy of science. We have Professor Masuda of Carnegie Mellon University, who specializes in digital enterprise architecture. And we have Dr. van Sinderen, expert in semantics, in cybersecurity and services. Unfortunately, for personal circumstances not present today, is promoter Professor Iacob. I'd like to ask the candidate and his paronyms to please come forward. Dear candidate, are you ready for your defense?
Highly esteemed rector, I'm ready to defend my work.
Thank you. Then I would like to give Professor Assar the opportunity to open the questioning.
Thank you, dear Doctor. Let me first say, dear candidate, that I'm very happy to be here and participate in this committee. Thank you for inviting me. As I mentioned in my report, I appreciated very much the work that you have done, in which there is a huge contributions in terms of methodology, in terms of new knowledge. You have combined different approaches, and you have proposed different artifacts and different contribution to knowledge. I had one question, which is partly practical, concrete and more philosophical maybe. In one of your appendices, the Appendix H, you extracted where you present the data that you extracted from the Intelligence Amplified applications. You have a grid, and in this grid there is certain elements. One of them is requirements, and the other is evaluation. And when you look at the data that you extracted, the requirements and the evaluation are those that have been the less mentioned in the papers and the studies that you made. So only 5 papers out of 54, 53, 54, yes, contained the requirements, and only 6 contained evaluation. Now, how can we design systems without requirements, and how can we consider research project or research design without evaluation? So let me know what you think about and how you understand this situation.
Highly learned opponent, thank you very much for this very interesting question. I agree that the development of systems must be based on clear requirements at the beginning, up front, and also clear evaluation after implementation. Within this research project of a limited time span of 2 years, I had 9 months to actually devote to the development of this system. So due to practical reasons, the number of evaluations is limited. So this is also acknowledged in the last chapter. But we did try to conduct multiple evaluations. So in chapter 4, you see the methodology that we followed of Wieringa, where we have treatment, problem investigation, treatment design, and treatment validation. And for each phase, we try to do different types of evaluations. So based on the requirements that we elicited, in each section, we present evaluation data. So to verify if we solve the right problem by having potential users of the system surveyed. After designing, we did semantic consistency checks using the Onto UML language that we use. We also evaluate or validate the system, I must say, using competency questions to actually run the system and check it. So this way we try to address it.
Yeah, my question is not about the evaluation that you made for your artifacts or the requirements that you had for your own artifacts. My question is that the studies that you mentioned in your literature review, those intelligent amplification applications, most of them don't contain requirements and don't contain evaluation. Okay. So would you consider still these papers as design science research if there is no requirements and no evaluation? How can we do design without requirements? For example, there is one of the papers that talks about an intelligent wheelchair and in 2020. So it's a recent research study. And for this intelligent wheelchair, apparently there is no requirements and there is no evaluation. So how could they design a system if there is no requirements? And how can they know that this design fits with non-existing requirements without evaluation? I wanted to know how you think about this situation.
Yes, yeah. Yes, sure. As mentioned in the analysis of these different contributions in the literature review, I point out the limitations. So we also you see that only 5% uses requirements. I like to use requirements in my work because I think it contributes to rigor. However, as also in chapter 3, Peffers mentioned, there are different entry points for design science research. So we could also design software to solve a problem. Or if we have an innovation goal, something we want to try out that hasn't been done before, we can use a goal-oriented approach instead of a requirements-oriented approach.
Okay, thank you.
Professor Assar, you have any further questions?
No, thank you very much. Thank you.
Thank you very much. And I would like to move to Professor Karaca to continue the questioning.
Thank you, Mr. Rector. Dear candidate, dear Sebastian, thank you for producing this very interesting and very exciting to read work. It was a pleasure to read it. I also had the pleasure to meet you and discuss your work last year at one of the conferences of our community in my current hometown of Groningen. I also would like to say that I was very glad to see such artwork in your thesis, and that also amplifies through the chapters. It was also really pleasant to see. I would like to come to my first question, which is related to the actual definition you use for intelligence amplification, and mostly in terms of the technologies that you envision to use to realize intelligence amplification applications. What is your actual definition? It is obviously in the thesis, but just to start the discussion.
Highly learned opponent, thank you for your kind words. And, it was a pleasure to be in your doctoral consortium workshop to present the initial ideas. This paper also included my definition of intelligence amplification as introduced in the layman talk. Because this work is part of the information systems discipline, I focused on information technology artifacts. And these information technology artifacts can be any kind of piece of software, piece of hardware. To make it a little bit more concrete, it can be a dashboard that enhances our capability to assess and to detect, for example, deviations in a process. It can be an algorithm that helps us to predict the future, for example, for sales or in logistics for the demand that we expect next day. So all kinds of IT-oriented artifacts can be placed within this definition.
So based on your definition, if we consider that, for example, in software engineering is a field, or the field of AI and other related cyber-physical systems, cybersecurity, how would you convince the colleagues from these communities that actually what you're doing is different from what they are envisioning with their technologies?
That's a very good question. I think that both fields are very much related to information systems. And information systems also has quite fluid boundaries. So we leverage knowledge from computer science, but also from economics, for example. So I wouldn't say it's necessarily fundamentally disruptive, very new, what we're doing. However, we try to emphasize on the amplification of a social technical system. So whereas computer science often focuses on technology and artifacts, in my definition I try to merge both together. So it's a human-centered approach to amplification, to software development. But it reuses a lot of existing approaches, technologies, knowledge.
So to what extent does the body of knowledge that you define in your thesis support exactly this focus on the human interacting with the software systems and being supported and its intelligence, or their intelligence augmented by these systems? So that the difference is clear.
Yeah, okay, thank you. There are quite some studies out there that are focused on human-computer interaction, which is quite a research field within computer science. So it's not new. There are quite some papers out there, and what surprised me the most is that Douglas Engelbart in the 1960s already proposed a human-centered design theory for intelligence amplification.
I would like to go to my next question, which is related to the tools that you have presented that can be used by companies to design their research projects, which I appreciate very much, especially because my background is related to software systems and tools that can be applied in different application fields. My observation, though, is that typically the result of the use of these tools is the running software that is the actual application for a specific context. So what are your ideas for the future steps based on your thesis related to how can you operationalize the decisions made in the design of the project so that in the end you obtain running software, which may be very complex?
Indeed, thank you. So in my work I focus on supporting the design process first, so the initial steps. We experimented a lot in design workshops and also building prototypes that can be validated within a limited space in a pilot project, for example. And as spin-off of these design workshops, we conducted a few case studies within organizational settings, where we try to transfer the prototypes and the ideas from the design phase into an actual system that can be used and evaluated in an operational context. We have some examples which are not totally documented in the thesis itself, but there are some references. For example, at a large international retailer where we, together with software developers, actually built a system that we could evaluate within the company. But this is, as I also point out in the last chapter, one of the areas of future research. And here the knowledge base that is developed can be of great value for people who actually want to develop applications and bring them to their organizations and see if the concept works and if there are actually intelligence amplification effects to observe using empirical studies.
Thank you. In the same context, do you think that it would be a feasible solution to create software tools that automatically produce the required or the desired intelligence amplification application based on your body of knowledge or the database of knowledge?
Yes, so this is a very exciting time to live because these tools already are present here, such as ChatGPT, but also Meta has produced a large language model where you can generate software, but also the whole software company using one user story. So there's a lot of tools that can help us to put ideas into working code and deployable software units quite fast. But that was unfortunately not feasible to do in 2 years.
Understandable. I hope that you don't, at the moment, would not trust ChatGPT to create an application that you immediately apply, but the idea is the same. Mr. Rector, do I have time for one more question?
Of course, yes.
Thank you. Dear candidate, could you please ask one of your paronyms to read Proposition 1?
Propositie 1 voorlezen.
The propositions related to the contents of the dissertation chapters. 1. Essentially, a human and an artifact can together produce an intelligent amplification effect that can be measured in a given context. Chapter 2. 2.
This is
Design.
enough. This was the
Sorry.
one we were interested in. Thank you very much. Thank you. So my focus here was grabbed actually by the word measured, of course related to the human and the artifact. And coming back to the context of operationalization and having the intelligence amplification or intelligently amplified application. So how do you think could we measure these intelligence amplification effects of the application that you have produced? Because so far you have the body of knowledge that you have identified that you can use to build these applications, but then how will you measure the effect based on the existing software?
Thank you very much for selecting one of the propositions. I'd be happy to elaborate on this one. In chapter 2, we surveyed quite a lot of definitions, and also the definition I use emphasize the measurement in a given context. And when we zoom into measurement approaches in chapter 2, there are 4 established approaches that we could use. One I highlighted in my layman talk, it's by Rogers and all, which measured the output, the performance of a human conducting a specific task, and compare this to a human conducting this task with an artifact. And there, by comparing, you could measure if there is a performance increase, if the performance is the same, or it even drops. So this is a quite straightforward way to measure in a given context for a specific task what the performance increase could be. Next to Rogers, there are also more sophisticated approaches. One of Fulbright, for example, who developed a representation information technology, which actually tries to go into the information process and see what normally humans would perceive and would process in their brain using cognition, using their intelligence, and what kind of cognitive work is being done, how much energy we need, brain power, and what is the actual output. And in this approach, Fulbright proposed to compare this to the computational intelligence. So computers can also perceive, they can process, they have different components that can execute tasks, and also have a specific energy usage. And there are a set of equations in my thesis how you could actually measure the amplification effect, and also 4 other effects, such as cognitive efficiency, cognitive density, to name a few.
In my view, most of these approaches are related to the design time evaluation of the application. Can you imagine any kind of approach that could be used at the time when the application is being used operationally, where you cannot really compare in the ways that you explained?
Yes, so there are modern development environments, for example in CoLab, online interactive environment, you can see how much time is needed, how much CPU is used, how much storage is used, and yeah, by handling data you could obtain some metrics also in a runtime environment, I would say.
Thank you very much. Thank you for your answers. Back to you, Mr.
Thank you, Professor Karaca. I would like to ask Dr. Daneva now to continue the opposition.
Thank you very much, Mr. Rector. Dear candidate, I enjoyed our discussions last week at the EDOC conference. I asked a lot of questions about research methodology. Now my current question is inspired by proposition number 4. Would you please kindly ask the Paranym to read out proposition number 4?
Okay.
Part 4. In the spirit of Lewin's quote, there is nothing more practical than a good theory. Design theorizing should not solely be done by theorists. Developing a theory for design and action requires collaboration between scholars, professionals, and practitioners throughout the whole process.
Thank you very much. My question is about the collaboration between professionals with different background, different agendas, and different ideas of commitment, scope of commitment, and scope of contribution. So theory building doesn't happen overnight. And as a matter of fact, it requires prolonged, very active collaboration over a significant period of time, sometimes could be more than a year. How sustainable this collaboration might be for an extended period of time? What are your thoughts on this?
Thank you, my learned opponent, for your question and nice talks last week during EDOC. Really appreciate that. If I understood your question right, it's about the different considerations to take into account to invest time.
Yes, and how you made it work, and can I borrow your template and process and just replicate it?
Okay, yeah.
But tackle my questions one by one.
All right.
So how did you make it work over an extended period of time?
Over extended period, yes. So in chapter 5, where we discussed the different design artifacts, I spent 2 years to develop this design canvas and let it iteratively evolve into a design method and design principles to extract. So it took quite some time to come to the underlying principles. So I would very much agree with you that it takes years to build good theories. This is also something that's acknowledged by scholars like Gregor in the field. So we need cumulative development, intermediate artifacts, and also learn from those. So it takes a lot of time. So we need to dedicate this time somehow in a project where we need commitment of not only the scholars involved, but also people who are actually going to use it. So they should be motivated and see a business case to invest a longer period in time to work on such an artifact. And this elicitation of this design principles was actually one of the tasks that we could do at the very, very last. So having all these case studies, design workshops, we could have a look at what are the outcomes of these workshops, what are the common denominators, and using templates from literature, we elicited 3 design principles that you can reuse, which is joint inquiry, collaborative design inquiry, and the measurement of intelligence amplification. And we try to put this together in a design theory to make it useful for not only scholars but also practitioners how to design these applications. So in terms of form, function, scope, requirements, but also how to implement this and evaluate it. So it encompasses quite a lot, but we try to make it available in very actionable form.
So you suggest translating your scientific output into practical terms so that the practitioners stay on board and have their interest over a period of 2 years. If this is the secret sauce, can I replicate it in any empirical study that requires theory building? To what extent, what kind of profile of individuals do I need on board to do it?
So if we want to stick to the recipe, the secret sauce, then I can also give you the recipe, which is in the methodology that we followed. So I think the experiments that we did can be partly replicated, also for similar projects. However, if we want to generalize, I think we should go back to the methodology that we approached. And we used the collaborative design inquiry of POR established approach that uses with learning communities and communities of practice to bring these people together and have fruitful discussions and co-development together. So I think the underlying methodology is better to generalize than the actual action design research. However, this is also based on principles using the method of SIGN. So I think you conceptually can reuse quite a lot of it.
Thank you very much. I consider your answer satisfying. One other question related to this but different. You came up with reference architecture. So far, so good. But if we want to see it used in company sites, how do we convince the business users to actually take advantage of this? Because businesses are not very forthcoming, borrowing reference models. This was my experience from the SAP world. Could you comment on this?
Yes, for sure. So reference architectures encompass a lot of theory and knowledge and expertise, of course. However, practitioners can experience them as being overcomplete or not necessarily, and in general also like to come to solutions. So I think having a reference architecture is good, but we also need concrete examples of this architecture. So solution architectures derive from this reference architecture that actually show applications in a specific domain and bring evaluation data that is compelling for practitioners.
Thank you very much. Thank you. I pass the word to
Pass the torch.
other.
Thank you, Dr. De Neva. Then I would like to ask Professor van Hilligersberg to continue the opposition.
Thank you, Mr. Rector. Dear candidate, also my compliments for your thesis. Very nice piece of work, very important topic. Well done. And I also compliment you for the enthusiasm in which you always, apart from all your writing and reading work, embrace working with industry, because you are really, I think, an ambassador for bringing AI to the logistics industry whenever you have the opportunity, and convince companies to start working and learning about AI. So I think that is to be commended. I like, of course, to ask a few questions. The first one on chapter 2, where you pick up the challenging task to I don't know if that's your favorite topic, come up with ultimate definitions of what is artificial intelligence and intelligence amplification, hybrid intelligence, and so on, and doing a really extensive systematic literature review. Reading that, I was again puzzled because when I come to the section on hybrid intelligence, I think it's excellent concept where you say it's all the teamwork and the learning that is central. Whereas in intelligence amplification, what is central is augmenting human intelligence with systems. If you look today, I think hybrid intelligence, that's my proposition, has much more potential than intelligent amplification, given all the power of intelligence systems these days. So why do you focus on intelligence amplification and not on hybrid intelligence in your thesis?
Highly learned opponent, thank you very much for your kind words, and also a very interesting question. I think both terms are quite related, as I also emphasized in the thesis, and in the Venn diagram you also see quite some overlap in between both terms. I conducted my study regarding intelligence amplification, to go back to the origin. And hybrid intelligence is a term that has been posed more recently. And I think there are more commonalities than differences between both terms. In my opinion, intelligence amplification focuses more on one-way amplification of intelligence, whereas this hybrid intelligence is more based on interaction, on symbiosis, on a tight partnership. So in that sense, one could argue whether the one is better or less applicable for a given case. But for example, for simple tasks, I think one-way amplification would be more straightforward, whereas more complex systems that require constant input of the users and data changes over time, also the learning changes over time, there hybrid intelligence might be a better way. I
Okay,
hope
so
this answers your question.
yeah, I see opportunity for a second PhD thesis if you want to write another one on
Second one, no.
on hybrid intelligence, but maybe you first need a break.
We can look for a PhD candidate together.
Excellent. Well, I think it also has to do with the timing, perhaps, and intelligence amplification. But thanks for your answer. So, yeah, talking about motivation. So, why did you do this research? Why did you put in all the effort? You write it down in section 1.4, so you come up with all kind of motivations. And especially from you, I would have expected also a very practical motivation. But all the motivations you write down in 1.4 to 1.4.4 are very theoretical. But what is your practical motivation to do this?
The practical motivation is mainly described in chapter 5, which builds upon my engineering doctorate, which was very practice and industry inspired work. And in my final chapter in the PDN back then, I pointed out this more theoretical approach to get started with my PhD work, to develop this design theory, for example. However, in parallel, I continue to work on this practical motivation. And as you can read in section 5.1, the main problem that I address here, that we derive from conversations with industry partners, is that there is a lack of a comprehensive design approach. So there's lots of theory, lots of models, but there's no easy to get started with approach that is suitable for people from industry.
Okay, thanks. So it's then it's if you would summarize it in 1.4.5, then it would be actually that this altogether delivers a comprehensive way to actually address and implement these kind of applications in industry. I appreciate that. It's a nice bridge to another question I have, because on page 58, 59, you actually, it's good to see that, quote some work that our colleague PhD, Andrei Dobrkovic, also supervised by Maria, Iacob and me, did back in 2016, where we developed a kind of intelligent amplification tool for logistics planners on top of a planning game that TNO had developed. And that was already kind of framework, not as nice as yours, I admit. So I was actually wondering, suppose then, I think you know the application quite well. So suppose we would have had your knowledge base and your framework back then, how would we have made a better system? And what would be different?
Okay, so using this design science research knowledge base, next to having a system with all this design knowledge present, I also present guidelines for using this in design science research project. So the work you refer to is also based on design science research methodology, so I think that is a good start. Having this system in place, you could use the 10 steps that are outlined in my dissertation, starting using a DSR grid to have the main problems, the main input theories, also the main concepts in there, and position design science research knowledge contributions. So that would be a very simple starting point to get into the actual development. And the knowledge base can provide different constructs, methods, models, even ready-made technologies that you could reuse or at least consider when developing such a framework, which is specifically for logistics and for the amplification of scheduling processes. So within the knowledge base, you would find generic knowledge and theories to use, and potentially also case studies from logistics.
So would we have come up with different, because you remember we had 3 different types of intelligence amplification designed into that system. would you say then we would have come up with different type of intelligent amplification, or just with, let's say, more generic lessons learned and more reuse, so maybe a faster design? Or
All right, yeah. It's a kind of a speculative question, so in my opinion, using also the reference ontology could help to improve the representation information quality. So the models that have been drawn in the paper by André are based on more conceptual drawings. So I think reusing the concepts from the reference ontology would strengthen these models to give more meaning to them and also contribute to better reusability of it. And potentially you would come to different solutions, but that's hard to say now, I would say.
okay, thank you, again. I have one more question, but I have to look to the rector if there is time.
There is plenty time.
Okay, thank you, Mr. Rector. Then I will make it a long question.
Long question. All right.
Well, dear candidate, I appreciate your method. So you really well develop it and you test it in workshops, and people give good feedback on the usability and so on. Still, I wonder a bit whether you pay enough attention to, let's say, the downsides of artificial intelligence and intelligence amplification in general, because it also means for people a threat to their job, a threat to their security, maybe a fear of whether these models do the right thing, whether there's no bias, and so on, the ethical part. Do you think your method pays enough attention to these aspects? Because I think you run your workshop with very enthusiastic, or maybe it's you that makes the people very enthusiastic, but this is not a game. This is going to change the society at large. It's going to change jobs, and it should not be taken lightly, I think. It's not just a nice design exercise. Is there enough attention in your method for this?
I agree there is a specific research bias in the form of myself, being enthusiastic and looking for opportunities. However, in the design canvas, there is attention for the possible downsides of these intelligence amplification applications. In the form of the box, where we try to have a look at the social impact of this technology, and also the ethical aspects and the legal aspects as well that are in there. So at the first discussion, we try to have this on the table. Whether it's enough, that is, I think, arbitrary. However, acknowledging this at the very first contact creates a dialogue. And I think it's also up to the designer to be a responsible designer, to actually take into account the people that are using the system. Mm-hmm. For this reason, this whole design method is grounded in human-centered design. So we start taking a look at stakeholders, users, their needs, and also the potential side effects. Mm-hmm. Also taking into account usability knowledge to not make a tool that is very stressful in use, and take into account ergonomics and other disciplinary knowledge. Mm-hmm. So it's in there, but also throughout the method, there are different checkpoints that we have put in, verifications, also go-no-go moments where management needs to step in, technological reviews, where architects come in, and also end-user evaluations. I hope that answers your question.
Yeah, time will tell whether that's enough, but it's good that it's incorporated at least for now. So I'm satisfied, Mr. Rector.
Thank you, Professor van Hillegersberg. Dear candidate, we are yet to conclude whether you are being effective, but we can certainly already conclude you're being very efficient. So that gives us time to continue the opposition with one of your promoters, Dr. van Sinderen.
All right.
Thank you, Mr. Rector. Dear candidate, of course, we already had many opportunities to talk about your work and to discuss issues and questions and ideas. So my question is about a possible future of your work. Suppose now that you can operationalize your knowledge base and create a real system containing design knowledge that will facilitate the design of IA applications. Then my question would be, how do you ensure that the knowledge will be complete, correct, and consistent? And should there be one such system or many systems? And in case of many, should they be connected? And is there a need to have a kind of governance structure in order to ensure this consistency, correctness, and completeness?
I learned supervisor, thank you very much for being involved in this whole process and giving a lot of feedback. We had many talks. I think you asked at least 2 questions. Let me start with the first one, how to ensure the consistency of this knowledge base, if I got it correct. So in the design science research processes that are laid out in chapter 4, we have different ways of verifying, validating, evaluating knowledge. And we assume that knowledge to be included in the knowledge base has to become peer-reviewed and published in a bigger scientific knowledge base. So this is kind of the quality check that at least the knowledge that we tend to put in this knowledge base has been peer-reviewed and has been subject to scientific evaluation.
Yeah, if I may interrupt,
sure.
You also in the academic literature, you find opposing opinions, of course.
Yeah.
So if this is translated into knowledge that will be in your knowledge base, you have inconsistent knowledge.
It can be that some articles have inconsistencies, of course, because it's reviewed by people and people can make mistakes, of course. But it also has to do with the way that the works are interpreted. And there are different perceptions, different perspectives, different positions that one could place to examine and assess this knowledge. That's also something we had quite a lot of talks with Karaca about from philosophical perspective. We could have a look at what is actually the truth, what is knowledge, how is knowledge created, how do we ensure that knowledge is actually consistent and scientifically grounded. And on the other hand, we also have the views of practitioners in our design science research project. So there are different perspectives that one could put on the knowledge in the knowledge base, and one can also complement it. And if there are any consistencies, then having these perspectives and positions in there is also a good way to have systematic structured debate. And also to see how we can contribute to this knowledge, to make it better or to address specific problems that we found out.
Okay, thank you. So the second question that was
From
embedded was whether there will be one system under control of one owner or agency, or many systems, and should they be interconnected in that case?
Yes, so we also had very fruitful talks on this, whether there is just one big knowledge base here on Earth or in the online world. But I think when we look to the way how science is organized in different disciplines, there are already various knowledge bases out there. For example, in the natural science, in physics, we have established theories, methods, approaches that are very well developed, and in social science we have similar developments. So in that sense, I would argue that there are already different knowledge bases out there. This is also surveyed by GAS and all, who classified more than 160 different knowledge bases from design science research studies. So I think each design science research potentially creates its own small knowledge base with input knowledge that is used to develop an artifact or to evaluate it. And that's actually the problem that I try to address in my work. So from design science research, we go from one project to the other. So we got something developed, we publish it, and we move to a next project. And by having a reusable knowledge base, I think there can also potentially be less knowledge bases when we make reuse of them. So we don't reinvent the wheel in different studies. Yeah. So we can contribute to each other's work.
And if there are more and they should be interconnected, then you should have to define interfaces probably,
Yes.
to make this possible.
Yes. So one of the underlying principles of developing this reference ontology is that it should be interoperable. So translating this abstract domain reference ontology into an operational system, it already provides some interoperability in the form of APIs or query language that you can extract data from it. And more specifically, scientific databases already have a standardized format, .ris format, how to make metadata, for example, about publications interoperable.
Okay, thank you. So for a follow-up question, I would like to ask one of the paranyms to read proposition 2.
Graag, director. De tijd is verstreken.
Thank you, Mr. Beadle. Dear candidate and your paranyms, please take your seats again. And now I adjourn this public meeting of the Doctorate Board of University of Twente. I reopen this public meeting of the Doctorate Board of University of Twente. May I invite the candidate and his paranymphs to come forward. Dear candidate, the Doctorate Board of the University of Twente, represented by us, has examined your dissertation and the statements accompanying it and heard your defense. The Committee of Deans has decided, in accordance with Article 7.18 of the Law on Higher Education and Scientific Research, to admit you the degree of doctor. I request the promoter to carry out the appointed task.
Under the authority assigned by us by law, and on behalf of the Doctorate Board, I grant you, Jean-Paul Sebastian Piest, the degree of doctor, and all the rights that are attached to this degree. As evidence of this, we present to you this diploma, signed by the Rector Magnificus, the Secretary of the Graduation Committee, and your promoters, and validated with the seal of the University of Twente.
Ja, zo. Samen het diploma vast. Ja. Oh, ja, ja. Ja, hartstikke mooi.
Dear learned Dr. Piest, let me congratulate you also on behalf of the university on your acquired dignity. From now on, you have the right to use the title of doctor. This title implies that society can rely on the quality of your judgment, that you will act with integrity and transparency, and that you will communicate independently about the results and the social relevance of your work. Value the doctoralis as an honorable distinction and a well-deserved prerogative, but always remember the obligations imposed by it towards the scientific community and towards society. Please be seated. I now ask the promoter, Dr. van Sinderen, to read the laudatio.
Dear Dr. Piest, Beste Sebastian, most PhD students have followed a straight educational path to their PhD, from high school to university, from bachelor to master, and from master to PhD. Most PhD students sit behind a desk for 4 years and think hard and deep about a solution for a complex problem without considering conditions of practice. They obediently listen to their supervisors, who are supposedly wise and omniscient, and follow their instructions to the letter, avoiding unnecessary risks. They stay in their offices, except when a paper must be presented at the conference. They avoid teaching and student interaction. They want to minimize other commitments, have distraction which could be a distraction from their main goal, namely finishing the book, the PhD book. These cliches don't apply to you. You are not normal. You are extraordinary. Let me attest this statement. Your education path, since completing senior general secondary education, HAVO in Dutch, until embarking on a PhD, included a prof.dr. applied psychology, a bachelor human resource management, a master business engineering, a master international supply management, a professional doctorate in engineering in the topics of civil engineering and business and technology. And you always alternated or combined education with work experience. During a fast-forward traineeship after your bachelor, you worked 2 years on diverse projects at 3 different companies. And during your two master studies, which you completed in part-time, you worked 8 years at the Cape Group, a nearby company. And being at Cape and later at the university, you initiated and managed many collaboration projects to develop and introduce new technologies with and for companies. An unusual mix of alpha and beta, and of learning and working. The trigger to start a new education program or to work at the company was invariably the insight that your personal and professional development was slowing down because you lacked specific knowledge or experience, or because you wanted to break out of your comfort zone and look for new challenges. During your work and studies, you found time to write project proposals and participate in projects where your research could be applied, where people could criticize the applicability of your work. Unlike many PhD students, you like to help, teach and educate people, interact with students, but also to use students in case studies to validate your research. Your activities outside your actual PhD research are also exceptional. For example, your professional activities include being a freelancer for the Port of Twente, an initiative with companies, government and education and research institutes in Twente to strengthen economy and create more jobs in the logistics sector. And before that, you have been the initiator and active member of the so-called LSCM-tafel Twente, an active network group with logistics and supply chain professionals in the region. You are also involved in charity and volunteer activities, like being ambassador of the Sport on the Move Foundation to support athletes with a handicap. You visited athletes in Namibia, and you hosted athletes from Namibia in Enschede on the way to the Paralympics in Paris. And 5 years ago, you managed the logistics support for the Maarten van der Weijden Foundation during the 11-city swimming tour to raise money for the Dutch Cancer Society. But how did you end up at the UT? At Cape, you had various collaborations with our university and joint projects, often about optimizing the performance of logistic activities and developing new technology for that purpose. Among these was the Synchro-Modal IT project back in 2014, where in my recollection, you met Maria and me, your future PhD supervisors, for the first time. And Maria recognized your potential and convinced you, or maybe vice versa, I don't know, to make the switch to the university to focus on a new challenge, research. At the UT, you started an ND, a professional doctorate in engineering, which is a design and practice-oriented technical research program. The chosen topic was a familiar one, to develop an industrial platform for increasing acceptance and use of new technologies in the logistics sector. To raise the challenge, you combined 2 ND programs, civil engineering and business information technology. And you acquired a project, or actually several projects, that financed your own position. The result was outstanding, and the thesis was awarded with a cum laude. And then you decided to do a PhD on a topic that was less familiar and to finish it in 2 years' time. The results we heard today, approximately 2 years and 3 months after the start, which is not normal, considering you did this in parallel with project acquisition, project participation, teaching, and other activities. So what is your secret to success? I think this has to do with your personal traits and your acquired capabilities. You are not afraid to take new challenges, step outside your comfort zone, seize opportunities, and make an extra effort. You have a constant drive to improve yourself, to invest in lifelong learning, as you acknowledged by your Proposition 5. And you have a talent to bring people together, to engage and motivate them, and also help. And it also helps that you have a diverse educational background, practical experience, and a hands-on mentality. You have your own personal style that is very effective. Work independently to get initial results, and involve and interact with other people to get impact. In summary, you are Mr. High-Tech Human Touch, Mr. Design in Action in one person. This doesn't mean that the thesis writing was without issues. Just to mention a few. You struggled with having two separate main results, developed at different times in different contexts. You found it hard to connect these results and make a coherent story with a clear line of reasoning. And also the length of the thesis was a problem. Your tendency to perfectionism, to report on main and side results at the same level of detail, led to a very lengthy and sometimes hard to read draft manuscript. In the final stage of your PhD, you made major improvements on the readability and decided to make the appendices available online. As a result, we have now a manuscript just over 300 pages, with details on the reproducibility, case studies, and the collection and analysis of data in the online appendices, which I guess count for another 300 pages. To conclude, we, Maria Iacob and I, your academic mother and father, so to say, are proud of you. I'm sure that your partner Elisa and your family, friends and colleagues are also proud. I'd like to take the opportunity to thank Maria, who cannot be here today because of her severe illness, for making this PhD project possible and for her ongoing support and interest. We are confident that your approach to continuous knowledge development for intelligence amplification design will improve the current practices. I'm so glad that you have now found a fixed position at the university and will be able to continue your academic journey in which you can explore new territory and make impact together with other people. We will follow you in the rest of your journey. Thank you.
Dear young doctor, it's my great pleasure to also congratulate you with this performance. By being not just efficient but also effective, you have proven the first half of your seventh proposition is that your PhD journey comes to an end here. I'm deeply impressed by your work, and I'm also very proud to have you as a colleague. I look forward to working with you, supervising a PhD student together, amongst others. Yeah, lots of things to celebrate. And it's now to celebrate your achievement with the reception. So we're shortly going to close this session. With this congratulations, I also want to include, of course, your partner, your best friend, your dear ones here in the first row, and all other friends and family, colleagues present here in this room. Then I'd like to ask you to please take your seat in the hall with the paronyms. So we will leave the room in the following order. The beadle will lead, followed by the young doctor and his paronyms, the dear family and friends here in the front row, then the committee member, and then the rest of the audience. Outside this room, photos will be taken with the committee members, so I ask for your patience. That will only take a few minutes, and after that the reception will take place. Before we go out the room, I want to give you a brief opportunity to say farewell and possibly thank you to Professor Masuda.
Thank you very much, Professor Masuda. Dear Professor Masuda, Sensei, dear Yoshimasa, thank you very much for joining online from late evening in Tokyo. It was a true magnificent journey to work with you, to get connected on eDoc and to write papers together and work in the AI hospital. So, arigato mas, and see you soon. Thank you.
You are welcome. Thank you. Congratulations.
Yeah.
Then in conclusion, I close this public meeting of the Doctorate Board of University of Twente.
Kan ik dit hier laten leren?
Ja. Wij kunnen aan deze kant.